Hello, welcome to lecture 22. And what we are going to do is to finish the architectural styles of the component and connector view type. And so what we're going to address is how do we describe systems which behavior basically is asynchronous. They communicate through asynchronous messages. We'll see that most of them is through the publish subscribe relationships, such that you achieve high decoupling between them, such that because basically when you subscribe to an event, you actually are decoupled with from the systems that publish that type of event, and actually it allows the dynamic redefinition of the system in the sense that you can add in some configurations you may dynamically add new event publishers and new event subscribers. Then we'll go for the repository styles or repository styles that basically are a very well-known style that you already know that she's related with the management of persistent data, where you will address things like transactional behavior, so the ACID properties of transactions, so transactionality of the data, so that you can achieve some level of consistency when you have concurrent processes changing this data. And another thing that we are going to discuss in the class are then three other architectural styles that they are a bit transversal because they can be applied together with the other styles. And one is communicating processes. So how do you describe the synchronization and the communication between concurrent processes? Okay. So basically, how to describe the concurrent behavior of the system. Of course, we have seen other styles where you need to deal with concurrency, but here we are really focused on how concurrent elements or concurrent components communicate and synchronize. And then tiers. And it's interesting to look at the tiers and see what is the difference between the tiers architectural style and the layered architectural style, because tiers is a way to organize your system, organize the communication between the components of your system, so it's different from layered. So look at it and try to understand. And then we have automatic configuration, which describe the behavior of the system, where you basically change the way components connect, or the creation of new components during runtime, of the destruction of components during runtime. Finally, in this class, we'll draw the allocation view type, and basically all modules and components are allocated to people, files, and hardware, and that's so, for instance, all components are allocated to hardware is usually the traditional way to understand of a software architecture, where you see the real hardware or the computers interacting and through physical lines. Actually, this style has become probably less and less relevant, I would say, but we can discuss about that. Why? Because of all the virtualization that has been done of the hardware, which make it very easy to change in which hardware the components run. And do not forget what we said about what is the definition of architecture. Architecture are the difficult solutions that you need to take at the end of the project, and that are difficult to change. So, or the difficult decisions. So the decision about in which hardware we are going to execute our components, actually with the virtualization that exists today, is very easy to change. So I may even argue that these views are not so relevant today compared with the past. But in some situations can be relevant anyway, like security, and so to show how can you achieve a level of security in terms of support on specific hardware. And then the allocation to people, and is related how modules are allocated to people. So it's related how do you assign work to people to develop the modules. So read the chapters and the sections in the book, and see you in the class.